Welcome back to my channel. Now in this video, we will be going through the Eunos Primary School Practice Set 1 for Foundation Science. So if you are a standard student, you can still use this for a quick revision. If you are a foundation student, of course get ready to pause the video at the questions, try it on your own before you hear and listen to the explanation. Let's get started. As this is a year-end paper, the focus of this paper will be primarily on P5 topics such as respiratory system, circulatory system, reproduction of flowering plants, reproduction of humans. There will be some P3, P4 questions, but those are fewer. Let's start now. For example, this is a P3 topic on diversity of living things. Which of the following are characteristics of all living things? All living things is important. So all living things will grow. All living things respond to changes. Now, not all living things may move from place to place. For example, plants may not move from place to place. Of course, I'm not talking about plants like creepers or climbers that can move up a wall. We're not talking about seed dispersal. We're talking about the whole tree trunk itself. Right? So C is not the characteristics of all living things. So whenever you see a word all, you must be extra alert that may not that is something that is a clue to you to tell you, hey, be extra careful. So in this case here, the answer is only A and B. It's number 1. So let's move on. So if you have an option that is A, B, and C, then this could be something that's tricky and you may fall for this. So don't, okay? Next one, the sun is our only source of. Now, sun provides us with 2 sources of energy. That will be heat and light energy. Alright, so the answer will be number 2 for this question. Now, next one, Eugene made a model of the human body system. So they will learn a few body systems in depth in your primary school syllabus. One is a digestive system. Let's take a look. There's a balloon here. Doesn't look like part of a digestive system. You also learn about the respiratory system. A balloon can expand. This one looks like the lungs in the human respiratory system. This looks like the windpipe in the human respiratory system. Of course, the hole here looks like the nose. So therefore, this resembles the human respiratory system. Okay, and that's the answer. Number 3. So next question, a reminder for those using this for revision, just pause the video, try on your own, even if you're trying in your head, that's very good. Before playing the video to turn to the explanation. This is a P3 topic on the theme of interactions, on magnets. Sam wanted to use a magnet to tell direction, as in, is it north, south, east or west, telling direction. He prepared the setups shown below. Now, you could have done these 2 before, most likely. Now, we put a magnet on a foam, like a styrofoam that is on water. This is a floating material. So, of course, if it floats, and the magnet will always point in a north-south direction. Remember this, I repeat, magnet points in a north-south direction. So, it will turn on the water until it points in a north-south direction, then it will stop moving. So yes, this can be used like a compass, tell direction like a compass to tell you the direction north or south. Similarly for this, now it's tied to a string but it can rotate along the string, alright? So it will again rotate and point in north-south direction before coming to a rest. It means it will stop twisting around once it finds a north-south direction. So yes, this is also possible to be used to tell direction. This cannot, because it cannot rotate on the table. Now, if you are a P6 student using this, then of course you can think, oh, there's frictional force. But if a P5 student, ignore what I just said about frictional force. Mainly, this is not tied to a string, it's not floating on water, so it cannot rotate on the table. Okay? So therefore, the answer is only A and B, 1 only. Next one. Wei Ming received a gift box as shown. Now, he can see this, right? But he can see the box, but he could not see what was inside the gift box. Now, if the gift box is made of a material like transparent glass or transparent plastic or clear glass or clear plastic, of course he can see right through it. But because he cannot see the things inside, this tells you the material doesn't allow light to pass through. Right? Light could not pass through the gift box. He could see the gift box because when the light shines onto the box, the light reflects off the box into his eyes. He can see the box, but he cannot see inside the box. Okay? So this answer number 3, for example, the gift box reflected light from the lamp to the side is correct for looking at the box, but not correct for looking inside. It doesn't explain why you cannot see inside. So the answer is number 2 for question 5. The diagram shows the changes in the states of water. X and Y are processes. So typically from ice to water, there must be heat gain. And when heat gain, ice will melt. From water to steam, there still has to be heat gain, and it will evaporate. But if it's steam, then this will be boiling, not evaporating. So which processes involve heat gain? Both processes involve heat gain. Answer is number 3. Then where is heat loss? Heat loss is the reverse. When you change the steam to water, that's condensation that involves a heat loss. When you change from water to ice, alright, this is called freezing. To freeze water, of course, you have to make water lose heat to the environment. Now, if you go to a toilet, you tend to see things like that, a hand dryer. So you put your hand under the dryer, it will automatically turn on for a few seconds. It will blow out hot air. Why? Okay, after washing hands, of course the hands will be wet with droplets of water. So how does the hot air help the hand to dry? Well, you go through this thing, right? Do you remember this revision? Those in my class, you would know what is WET. Wind helps to increase the rate of evaporation. Exposed surface area more exposed surface area help to increase the rate of evaporation. And a higher temperature of the surrounding help to increase the rate of evaporation. In this case here, it's all about evaporation because the hot air and the wind that comes out helps the water to evaporate quickly and hence the hands will dry. Answer is number 2. I pause for a while for you to see this. Okay, let's go through now. This is an electromagnet. You can see rods around iron rod. Why is it iron? Because iron is a magnetic material. What is another magnetic material? Steel is another magnetic material. Either one of these material can be used to place here coil wires around it, close the switch, and ta-da, it becomes an electromagnet. Okay? Now, if you want to make the electromagnet stronger, why do I talk about stronger? Because it talks about increasing the number of iron pins. So you want a stronger electromagnet. A stronger electromagnet, you can do it in 2 ways. Either you increase the number of coils around the rod, so more coils, or next one, you will increase what? The number of batteries. So by doing these 2 things, you will increase the number of iron pins that can be attracted to the electromagnet. So add more batteries, increase number of coils of wire around the rod. Now, number C cannot. Why? What is aluminum? Remember, I talked about magnetic material. There are only 2, steel and iron, not aluminum. Now, for those who learn other things like cobalt and stuff like that, take note, I don't use those as materials for magnetic material, because in the primary school science syllabus, you only need to learn two, which is steel and iron. So if a teacher is teaching other things like cobalt, nickel, not necessary. Okay, a very simple question I ask you to prove to you why is this not necessary is this. Can you tell me how cobalt looks like? Can you tell me what's the color of cobalt? You see what I mean? So, because in your daily life, you encounter these two materials most often, definitely more often than the other two materials. Therefore, you just need to know these two as the magnetic materials. You need to know everything under the sun, okay? So the answer for this is A and B. Answer is 1 for question 8. Okay, we're halfway, almost halfway there. We're getting completed soon. Hanging there. If you want, you can take a break and pause the video. Wendy drew arrows to show the movement of water in a plant. This one is about the plant transport system. Now, a plant transport system, there are two things that transport things in a plant, right? The things could be like food and water. And to transport these two things, you need food carrying tubes, water carrying tubes. So how does water move in a plant? Roots absorb water, so this is definitely correct. When it goes to the stem will send arrow to other parts of the plant. So here definitely will be B. Answer is number 2. Question 10. Study this diagram below. Now you have thermometer. Once you have thermometer, it should be about heat. So you must quickly pick out the correct topic inside your brain. Once you know what's the correct topic, the correct kind of words and concept will come out. Right? You see temperature, you see ice. It could be about heat, it could be about matter, M-A-T-T-E-R. It could be about melting or boiling or something like that. Now, which of the following shows the reading on thermometers A and B when some ice cubes start to melt? Now, when they are starting to melt, the ice is gaining heat, right? The ice is gaining heat. Ice gains heat. But bear in mind, the melting point is still at 0 degrees Celsius. Only when all the ice has melted, then the temperature will start to rise. So long as there's still ice here, the temperature of the icy water here is still at 0 degrees Celsius. Okay? Okay, pardon the bell just now. You can guess where am I doing this video. So let's go to this. So the answer for number 10, right? Therefore, this is a big clue that tells you it has to be at 0. Because the ice is still melting. Not all has melted yet. Now, how about the water that is outside here? Alright, for B measures the temperature of water outside. Of course, the water outside will be losing heat to the ice. If it's losing heat, the arrow shows the direction of heat flow. If it's losing heat to the ice, of course, the temperature starts to drop. That's why it's below 25. Because the starting temperature was at 25 degrees Celsius. After losing heat, temperature will go down. Okay? Alright, next one, classification table. So materials. So you have S and T. Which are the headings for S and T? These are, for example, you talk about this, right? You talk about floats on water. Does it make sense to float on water? Well, fabric will absorb water and it will sink. So definitely wrong. I look at one side first. Flexible. Yes, I can bend fabric. Fabric is like your cloth. No? This is like fabric, right? Fabric material. So rubber, yeah, I can bend rubber. So this is possible. How about absorbs water? Rubber is waterproof. Does it absorb water? So just looking at this side, I can get the answer. It's number 2. But just to be doubly sure, let's check this side. Stiff. Stiff is the opposite of flexible. So metal is very stiff, not easy to bend metal. Wood is stiff, not easy to bend wood. So answer is number 2 for question 11. Question number 12 is an electrical circuit. Which of the following should be added at X? To decrease means make less. Decrease the brightness of the bulb. This means to make it dimmer. To make a bulb dimmer, we can do a few things. Remove the batteries. But since there's only one battery, if I remove it, it just won't light up anymore. So I cannot remove battery. I can add more bulbs. If I add more bulbs, then it will become dimmer. Okay, so yeah, I should add more bulbs. If I add more batteries, oh, it just becomes brighter. So answer cannot be 1, it must be 3 for question 12. Next one, question 13. 8 persons were trapped in the lift for 30 minutes. Which of the following shows the changes in the oxygen and carbon dioxide in the lift after 30 minutes? So people will need to, this is about your respiratory system, and you know that a human being will need to take in oxygen, and they will give out carbon dioxide when they respire. So oxygen level, if you take it in, right, they keep breathing in the oxygen level should decrease. It will decrease means it goes down. And it gives out carbon dioxide. Every breath we breathe out, we will increase the amount of carbon dioxide in the lift. So that is increased. Okay? So the answer is number 2. Now, this question is not going to be tested in your primary 5 syllabus exam because it's about photosynthesis. So I will skip this question. Okay? If you are a P6 student watching this, of course, you will need to know this. Then you can look at my videos on covering P6 topics on photosynthesis. Okay, this question is on plant transport system. Now, Dennis removed the outer ring. Bear in mind the word outer ring always refers to food carrying tube. If it's inner rings, then it talks about the water and food carrying tubes. So if you remove outer ring, only food carrying tubes were removed. So here, only food carrying tubes were removed. So that means that the food made in the leaves cannot go past this part that was cut. So all the food that were made will be transported down the food carrying tube, then they get stuck here. Cannot go down further because there's no way through it because the food carrying tube has been cut away. Same for this side. That's why it keep on accumulating and bulging. This becomes swollen or bulging. So after a few days, observe the stem above X was swollen. Why? Because the food made by leaves could not carry it to the roots. That's the answer. It's not about the water. Definitely not about the water. Alright? Because the water carrying tubes were not cut. How do I know? 2 things. The word outer tells me that, and here the teacher is so nice. They even tell you only the food carrying tubes were removed. See, they reminded you again, it's only food carrying tubes that were removed. Question 16, another electrical circuit question. We have 1 battery, 2 bulbs. One light up, one didn't light up. Is there something wrong with the battery? Let's check again. Now you see L and M in the same position here. Okay, now they swap these 2 material around. At first P was on top, right? P was on top, Q was below. Later on P was below. Okay, now he exchanged them and observed no bulb light up. So this tells you something. Now, if this light up, it means that this must be a closed circuit. Closed circuit means the current can flow through the material P, can flow through the filament in the bulb, and flow back. So this is a closed circuit. So P must be a conductor of electricity. So here, I'm not sure whether Q is a conductor or insulator of electricity. I'm not sure whether the bulb is working or not. So if I bring P down here, and if bulb M is working, bulb N should also light up, right? Let's check. So when P is down here, strangely bulb M didn't light up. So this must be spoiled. So in scientific term, when we talk about spoiled bulbs, they talk about them being fused. You can check my channel for a video on fused bulbs, right, done by my friend Aurelia. So that is on, it shows you fusing bulb means that the filament melted. Okay, so this tells you therefore which one is insulator. Okay, I know for sure the bulb M fuses is this. Okay, bulb M fuses, definitely that's the case. That's why it didn't light up. So which one is the insulator? I know for sure conductor is P. Is M an insulator? So when I move M up here, if M is a conductor, this should be a closed circuit and it will light up. Since it didn't light up, and we know that it was working at first, therefore Q must be an insulator. That's why current cannot flow through. So current cannot reach the filament, so the bulb didn't light up. So therefore, Q is the insulator. The answer here is number 2 for question 16. Okay, 2 more questions hanging there. Now, Joel prepared the circuit here. Now, 2 batteries, switch, bulb, another switch, and a bell. New thing. So, which of the following will happen when he close switch A and open switch B? So, closing switch A means close. Open switch B means keep it like that at the same time. So, will current flow? Let's check. Is there any gap in this circuit? Yes, there's a big gap here. Gap means it will be an open circuit. Open circuit means current does not flow. If current cannot flow, then of course these 2 things cannot work. The bell will not ring, the bulb will not light up. So bell would not ring, bulb would not light up. See, the word not is important. So answer is 3 for question 17. Last question. W is a solid at 45 degrees Celsius and a liquid at 170 degrees Celsius. Which is the possible melting point and boiling point W? So I will draw my model. So you're telling me that at 45 is a solid. So it's a solid here. Then at 170 it is a liquid. This means that the melting point, it must melt somewhere here. Melt. And it must boil somewhere above. Boiling must be after this, right? Boiling must be above 170. So let's check which is a number that's above 45. These 2 numbers are above 45. Which number is above 170? This is below, this is above. Okay, so answer is number 2. Now that ends the lesson for this. I hope this helped you in the revision. All the best.